All right, so this is an example of a variation of parameters for three y sub c's. So let's say you somehow managed to get your complementary solution to look like this. And this is the complementary solution. So this will be your y1, this will be your y2, and this will be your y3. So your w is going to look like e to the negative x, negative e to the negative x, and e to the negative x, e to the x, e to the x, and e to the x, e to the negative 2x, negative 2e to the negative 2x, and 4e to the negative 2x. And that would get you 6e to the negative 2x. Your w1, remember, it's just going to be zeros all the way down your first column, so 0, 0. And your f of x, e to the 4x, e to the x, e to the x, and e to the x here. E to the negative 2x, negative 2e to the negative 2x, 4e to the negative 2x. And you'd get negative 3e to the 3x as that, w2. So then you're going to replace your second column this time. Remember, it's always going to be zeros all the way down. So it's e to the 4x and e to the negative x, negative e to the negative x, e to the negative x, e negative 2x, negative 2 e to the negative 2x, 4e to the negative 2x. And that would get you just e to the x, your w3. You'd then replace your third column this time. So 0, 0, e to the 4x, and everything else is the same. And your determinant would be 2e to the 4x. Now remember, your u1 is the integral of your w1 over w, and that would be negative 1/10 e to the 4x. Your u2 would be w2 over w, and that would be 1/18 e to the 4x, and your u3, which would be your w3 over w, and that would be 1/18 e to the 4x. So your general solution should be your y sub c, which is this up here, plus your y sub p. Remember, it's going to be u1 y1 plus u2 y2 plus u3 y3. So you should get y is equal to c1 e to the negative x plus c2 e to the x plus c3 e to the negative 2x plus 1/9 e to the 4x, because when you multiply u2 and y2 together and u3 and y3 together, you'd both get, wait, that's actually kind of wrong. U1 is actually equal to negative 1/10 e to the 5x. U2 is equal to 1/18 e to the 3x. And u3 is actually equal to 1/18 e to the 6x. But actually, u1, y1, so e to the 5x, e to the 3x, e to the 6x, but u1, y1 is equal to negative 1/10 e to the 4x. u2, y2 is equal to 1/18 e to the 4x, and u3, y3 is equal to 1/18 e to the 4x. So you just plug in 1/9 down here because it's 1/18 plus 1/18 times e to the 4x, you get 1/9 e to the 4x minus 1/10 e to the 4x, and this would be your general solution. You can plug it back into your original equation. Should still work. But this is your general solution And of course, remember one last thing, when you're integrating your Wronskians here, you do not use a plus c in this case.